Okay, picking up where we left off from part A, with the cats and their weights. We have a question here. A certain female cat has a weight that is 0.5 standard deviations above the mean. What is the proportion of female cats that are heavier than this one? Okay, so when they say that the weight is 0.5 standard deviations from the mean, that's another way to say that Z is 0.5. Okay, because Z is how many standard deviations from the mean. And if it's above the mean, then it's going to be positive, and if it says below the mean, then it will be negative. So we know what the Z is, and actually we figured out the Z score for this in the last part. So let's just quickly check that. I think it's still sitting in my Desmos. Yes, so Z equals 6.5. We got about approximately 69%. Okay, however, that 69%, so the probability that it's less than half a standard deviation, well, from the last problem, half a standard deviation was 4.4 pounds. We found out that that equals about 6.69. However, the wording in this question is slightly different. So the wording in this question says how many cats are heavier than that one. So if we want to, so we don't want to find this, we actually want to find out this value. But in order to do that, we can just take 1 minus this. So let me just write that all out. 1 minus x less than or equal to 4.4. And we know that this is 0.69. Okay, and so we get 0.31. And that's our answer. 31% of the cats will be heavier than half a standard deviation above the mean. Okay, moving on to another problem. Okay, how heavy is a female cat whose weight is on the 80th percentile? Okay, so this is a new language here, the percentile. What the percentile is saying is that it's giving us the percent, or what our z-score actually will be. So whatever this weight, we don't know what the weight is. Let's say the weight is x, little x, then, but we do know the probability that something is less than x. That's what they're giving us here, the 80th percentile. So the 80th percentile will be when it's 0.8 from 80%. Okay, so how do we find this x? Okay, so we'll start with the z score. Okay, so we want to find a z score that we want to find a z that has a z score of 0.8. So let's go back. Again, as always, you can always do this from a table, and on the table you would look for the value that's 0.8, or as close as you can get to 0.8. And if I'm over here, I'm going to slide this around until I get to as close as I can to 0.8. Okay. Okay, that's really close. Okay, so z-score of 0.85. So if I want this to get into the 80th percentile, then I'm going to want my z to be 0.85. Okay, but that's not the question. The question is, what is the weight going to be? Okay, so we're going to use this equation here. Okay, and we're going to plug in everything we know. What we don't know is x. We do know z, so we know that z needs to be 8.85. We don't know what x is. We do know the mean, so from before the mean was 4.1. And we do know the standard deviation. The standard deviation is 0.6. So we just have some simple math here to do, a little bit of algebra here. I'm going to multiply that. Going to add this. Okay, so that little expression will give us the value of x. One little neat thing, you can just do this in Desmos, so we don't need to open up another calculator. Plus 0.1. Okay, there we go, 4.61. So the answer will be 4.61 kilograms. And let's just be clear what this means. So this means that 80% of the cats will weigh less than or equal to this. Okay, so that's what that means. All right, so a random female cat is chosen at random. What is the probability that she weighs more than 4.5? So the value, well, okay, let's put this in probability distribution. We are trying to find the probability that x is bigger than 4.5. Okay, so we're going to want to find out the z-score of 4.5. So we'll just put in 4.5 minus 4.1 over 0.6. We'll get 0.4 over 6 equals 2/3. And if you remember from before, I said 2/3 is a benchmark. When you have a z-score, it's actually going to be the 75th percentile. We can come over here and verify that. 6.6, okay, 0.67. Pretty close to 75%. And if you round it off to nearest percent, it's going to be 75%. Okay, so but again, this is actually the probability that x is less than 4.5, because the z-scores are always going to give you the probability that it's less than that value. And what we're looking for is this, the opposite. So all we have to do is subtract from 1. So why don't I just go up here and so this is going to be 1 minus 0.75. Okay. All right, there's our answer. 25% of female cats will weigh more than 4.5 kilograms. Okay, let's move on to some more difficult problems.